Hi everyone. This will be a very short lecture on the remaining concepts of machine learning. So we have already covered concepts like PCA, linear regression, logistic regression, k-means clustering, bias variance trade-off, and many others in advanced machine learning. But essentially, there were two left: K-nearest neighbors and support vector machines. So we'll be covering both of those lectures today. Right? Let's start with K-nearest neighbors. K-nearest neighbors is a supervised algorithm, which means that the tags or the labels of the data are there along with the data point, right? So, say for example, I have an image of a cat or a dog. So, the label, whether it is a cat or a dog, is there along with the image, right? So, that is not the case with unsupervised learning algorithms where the label is not there. So, the image is the only thing that we have. We don't have the label or the tag along with the image, right? So in supervised learning algorithms, we have the tag or the label along with the data point. And K-nearest neighbors is also a classification algorithm, which means that it is used to classify a data point, right? Whether it is a cat or a dog. So say for example, this black data point, whether it belongs to the green class or the brown class, right? Whether it is green or brown. So K-nearest neighbors helps us identify that. So it helps us classify this data point. That is why it's known as a classification algorithm, right? Now moving on to the algorithm. So we'll talk about this algorithm from with the help of this basic GIF, and that will help you understand what is K-nearest neighbors.
So let's say this is a new data point. We want to classify it in either a green class or a brown class. And it wants to find its, so how does it do this classification? It finds its nearest neighbors, 5 nearest neighbors. We have specified K to be 5. And these are the 5 nearest neighbors. 3 of them are green, 2 of them are brown, right? In the 5 nearest neighbors circle. Now, since only 2 are brown and 3 are green, it is imperative from this algorithm that it will be classified in the green class. It also has to be classified as green. That is the case, right? I think most of you have been able to understand this. Um, and these are the steps. So KNN assumes that similar things. So this is the assumption that KNN algorithm assumes that similar things exist in close proximity. That is the assumption here. That okay, we have 3 green algorithms. We have 3 green data points and 2 brown data points. Then it is imperative that this will also be a green data point that way. And these are the steps. We first initialize K to the chosen number of neighbors. In this case, K was 5. And then we calculate the distance between this data point and the other data points, right? And then add the distance and the index. Now this becomes a bit mathematical here. Add the distance and the index of the example to an ordered collection. Then we sort the distance. Then we pick the first K entries from the sorted collection, which means that it will give the nearest 5 neighbors here. And then finally, it will return the mean of the K labels. And in case of regression, in case of classification, it tells the it returns the mode. What does this mean? This means that whichever value has the whichever data point has the highest value. For example, in this case, green had three. There were 3 green neighbors, right? So that kind of a thing. It will return the mode. In this case, green 3 was the mode. Green was the mode. So green was the maximum number in this circle. That is K-nearest neighbors. This also gives a good idea. So we have labeled data of 2 classes, A and B. This data point needs to be classified. So first they'll decide the value of K, which is the K-nearest neighbor, right? It will be classified to a class whose data points are maximum nearest neighbors. So in this, if you can see, 3 are triangles and 2 are squares. So it is imperative that, okay, K is 7. So it's a bigger data point. It's a bigger circle. So here we are changing K again and again so that we get a better picture of this. We get a better idea of whether this data point has to be a triangle or a square. That is, we try to adjust the value of k according to, or we can even compare. For k equal to 5, we have something. For k equal to 7, is the classification algorithm giving the same result? That kind of a thing. So here we have 3 and 3. Both, okay, we have 3 and 5 actually, in case of 9. So I think you've gotten the gist. Every new data point will be classified according to the k nearest neighbors. Okay, that is KNN. Any questions till now? All right, let's move to the last algorithm within machine learning, which is SVM. SVM is basically it's an easy algorithm, support vector machines. We are trying to separate in this algorithm. We are trying to separate the data points by a line, by a hyperplane. Now this is called a hyperplane. So we are trying to separate. Let's say this is one class, this is another class. There's a lot of distance between these two, right? So initially we just had random data points. There were some data points here, and then we had some data points here. There was no classification done before that. Now we noticed that there's a lot of distance between this. The perpendicular distance is high between these two classes, right? So we'll draw a hyperplane here, which will separate both these classes. Now this becomes one class, and this becomes a second class, right? That is, now finding this hyperplane. That is our task. That is, and that task is done by SVM, support vector machines. Now there's a few characteristics of this hyperplane. First one is that this is basically called a maximum margin hyperplane. The margin here and here is the maximum, right? We want the hyperplane to be exactly in the middle of this distance. We want the hyperplane which has the maximum margin or the maximum distance from the nearest data point, this one. So this is hence called the maximum margin hyperplane. Now the nearest data point here is this, and the nearest data point in this class is this one. And these nearest data points are also called support vectors, right? This might be a lot of terminology. That is totally fine. Just go back and I have already shared the slides. Go back and go through the slides. If there's any question, you can always ask in the next session or comment in the classroom. Or I've also shared a few blogs. I think I've shared a few blogs. I'll be sharing more soon. So I'll be sharing more tomorrow. Feel free to go through some of them. If you want to go into very deep into machine learning, then you can follow some courses. I've already given some recommendations in the slides. There's one full slide dedicated to what all courses you can do, right? So now let's come back to support vector machines. The nearest data points are called support vectors, and this is the maximum margin hyperplane, the center one. This is called the, now this side is the positive hyperplane, this side is the negative hyperplane. Don't need to go into all of that. So just understand that if we have data which is separable linearly, right, we are separating this data using a linear, basically a line, right, a straight line. If the data is separable linearly, we find the hyperplane which maximizes the minimum distance between the closest points from different classes. Now this is also called the optimum hyperplane. Right. Now these are a few points. Practically, not many such cases exist. So we try to build a classifier which is nearly linearly separable. Now there is a possibility that you'll get some of these points here also, right? And there's a possibility that you'll get some of these blue squares or diamonds here as well. I'll just show you. So there's a possibility that you get a diamond here as well, right? So that is totally possible. Now we are not trying to find an exact kind of a thing. We can work with nearly linearly separable things also, because not all data distributions are linearly separable, right? Then support vectors are data points that are closest to the hyperplane. And these are the ones which are actually deciding factors. These decide the position of the hyperplane. Now, if the data point is a bit here, right? If this orange data point is a bit here, then the hyperplane will automatically adjust to something like this, right? So that is support vector machines. This also gives you a better idea. Right. So see this. This has a smaller margin if we choose this hyperplane. But if we choose this one, if we choose this one, then it will give a big margin. That is why this is not the correct one, and this is the correct one, right? This is a bit easy. I think you guys must have understood. And in 3D, if you see, right, this is the kind of uh, the hyperplane looks like this. These are your data points in 3D, and this is the hyperplane. I think GIFs you can help you explain better. So these GIFs, I think you'll be able to understand now. Any questions till now? All right. So SVM and SVM and K-Nearest Neighbours, these were two algorithms left within machine learning. I remember last time we had discussed this in depth: accuracy, precision, recall, and F1 score. I think I don't need to recap this. Accuracy is how accurately we are predicting. Now, precision and recall are, I think you can understand using this description. And recall is again something similar. F1 score essentially combines both precision and recall because it is a weighted average of precision and recall. This is the formula of F1 score. So you can again go through this slide. And I've discussed with you last time that we'll go through SQL now.